Student, in this video, I'm going to explain sum difference identities. And later on, we are going to use these sum difference identities for double angle identities. So first of all, what is sum and difference? Sum is plus, difference is minus. So let's take a look at this warm up and see if it is a true statement. So let's say x is, I'm going to change this to the radians pi over 2 and y is a pi. So if I say sine x plus y, which is pi plus pi over 2, which is 3 pi over 2. Think of that way if I add these two. So pi plus pi over 2 is a 3 pi over 2. So 3 pi over 2, what is sine of 3 pi over 2? Sine of 3 pi over 2 is down here and it's negative 1. So can I separate that? That's a sine pi and sine pi over 2. Can I say they are same? So clearly you can see that sine pi is a 0 and pi over 2 is a 1. So 0 plus 1 is 1. So how can this be sine 3 pi over 2 is sine pi plus pi? This is negative 1, this is 0 and 1. They are not same. Okay, so let me explain the purpose of this again. If you have sine of, giving you another example, if I say a plus b, this is an angle. Remember, this is an angle. So is it possible that we distribute? Can I say sine A plus sine B? No, that's not possible, because if we know some knowledge of horizontal transformation, we have this is a horizontal transformation of the angle. If the graph has shifted sideways, you can never say that is the same as the sum of the two sine. Never, never, never. So in other words, again, we call them, I give you another example is, if you have, we have learned logs. So can I say log 2 plus 3 is log 2 plus log 3? No, that's not true. We know that they are not same. This is a horizontal transformation. This is a two y values. They are not same. And also log properties, we know that the sum is multiply that. They are not same. They are not same. They are not same. Okay, so cool lesson we have here is how do we rewrite then? If we have some of something, what do we do? So let's quick warm up is how can we write as a sum or difference of this? So 23 over pi is a big number. How can I break it down? Because 23 over pi is not on a unit circle. And we know only the angles of unit circle. So again, think about this again. Purpose is we have to evaluate this without calculator. So that's a purpose. How can we, 23 over pi is not on a unit circle. So how can we split this into two angles? So the purpose here is, you know that 23 is a big number, so we have to add. And I'm going to show you the coolest way to add the two angles. We have to make 23. So can I write 20 and 3? 20 plus 3 is 25, 23 pi over 12. Okay, so what is 20 pi over 12? Is it on the unit circle? So think about 20 and 12, they both goes multiple of 3. So can I say 5 times 4, 5 pi over 3, and this 3/4 is, are these on a unit circle? Yep. So this is our job. So now many different ways you can do it. So we can say answers are not unique. Pi over 12 is a small angle, so which will tell you you have to subtract. Let's make it 12. Easiest way to get 4 pi is, can I say 4 pi minus 3 pi? Well, let's check. 4 pi over 3, 12 is, can I say pi over 3? 3 pi over 4, can I say pi over 4? Do we have these angles on a unit circle? Yes. Some student says, can I write 5 pi over 12 minus 4 pi over 12? You would get pi over 12, yes. But is 5 pi over 12 on a unit circle? No. So you can't. You can't. You have to use spatial angle. Spatial angle means angles on the unit circle. So let's take a look at some formulas, and you are expected to memorize the formulas, and you must know all these values forward, backwards. I'm not going to explain this unit circle. You have to know this. You got to know this. You got to know this. Okay, so what are those cool formulas? So we have 4 sets of formulas and you are expected to know. We are not going to derive them. Deriving is taking a long time and you just have to know them and use them. So let's talk about this first one. Cosine x plus y is cosine cosine sine sine. Cosine x minus y is also cosine cosine sine sine. What's the difference is this, which means sign changes. So one more time, cosine have a different sign. Check, if it is a plus, then it's a minus. Minus, it's a plus. So generic way, we write this as a plus, minus, minus, plus, which means the top sign goes with the top, bottom goes with the bottom. So I wouldn't recommend doing this. I would say this is formula number 1, formula number 2. Now let's talk about sine. This is number 3 and number 4. You gotta remember all 4 of them. And we will use them in a memorization quiz as well. So let's talk about the sine formula. What would be sine? Sine x plus y is a sine cosine, cosine sine. Keep the x, y as it is. Just switch the function. And sine x minus y is the same thing. Sine sine, cosine cosine. I'm sorry, sine cosine, cosine sine. Now the difference is the sine does not tell students to memorize such a easiest way. Sine get the same sign. Okay, sine theta get same sign. That's other sign. Sine get the same sign. Sine get the same sign. That means if it is a plus, plus, minus, minus. So let's practice with how do we use them. You have the only way to know them is use, use, use. It become muscle memory. Number 1, number 2, number 3, number 4. You have to know all these formulas and use them. So let's start one. Exact value means no calculator. Answer in fraction. Answer in fraction. Okay, so 13 pi over 12. What combination would you use to get 13 pi over 12? So, like I explained, 13 over 12 is a big number, so that means you add. Get the combination of 13. Can I say 6 and 1? But then 1 pi over 12 is not on a unit circle. So, can I say 6 and 7? That won't work either. So, what would you use? Will give you pi over 12. Pause the video for a minute and figure out. So, I would say 4 and 9. 9 plus 4, 13. 4 pi over 12 is pi over 3. 9 pi over 12 is what? Multiply by 3, right? So that will makes it 3 pi over 4. And this combination will work. So let's talk about how do we show the setup. Like I said, how this, the hardest part is to get the combination. And I showed you, make it 12 and I'm done. 6 and 9, 4 and 9, my bad. So what do we do next? So 3 pi over 4 and pi over 3. So let's work. You have to show that sine is a combination of, doesn't matter which one comes first. Doesn't matter which one comes first because a plus b is the same as b plus a. So let's use the formula. Formula is sine 3 pi over 4 cosine pi over 3. Remember alternate. Sine get the same sign. So plus cosine 3 pi over 4 sine pi over 3. You must know unit circle values. So keep those keep those parentheses and you have to get all these values from the unit circle. So you have to know second quadrant, who is positive, first quadrant, everybody's positive. So I'm going to bring my work here. Parenthesis. This number is that. Okay. Now let's come back to algebra piece. They are multiplying 2 times 2, 4, root 3 times root 2, root 6. 2 times 2, 4, and root 2. This is your answer. Do not go further. This is not square root 4 over 4. That is wrong, wrong, wrong. You cannot do anything. Those are two radicals. Remember, you cannot do any work there. So pause the video here and do this for cosine. So we can use the same combination, cosine pi over 3 and 3 pi over 4. Same combination, but we are using cosine. So what's the formula is cosine, cosine, opposite side, plus means minus, sine, sine. Make sure you show 4 parentheses big like this. Get in a habit of correct math. Pi over 3, 1 half. Cosine is a negative in a second quadrant. Root 3 over 2. Cosine is positive in a second quadrant. And negative root 2 over 4. 3 times 2, 6. And final answer, you can just leave it like this. So they are very similar looking answer. Why? Because many numbers are always repeating on a unit circle. So this is a example for sine and cosine. Let's check it out. Okay, so I would like you to pause the video here and get the combination for 5 pi over 12 and pi over 12. Try these two examples, pause the video and check the answer. Check the answer. One more time, I highly, highly, highly encourage that you show this, because if it is a negative answer, you have to keep negative. Second quadrant, cosine is negative. For this unit, also you must know small, medium, large, and based on the quadrant, you have to have a positive, negative signs. Okay, so let's flip the paper and we figure out how to work backward. How to work backward. So read the directions for each, simplify to each expression, writing in terms of sine or cosine. I should say sine or cosine. Okay, so read the formulas, sine, sine, cosine, cosine. So is it sine or cosine? So you know that they are both same. They are both same. So that means it is a cosine formula. Cosine, cosine, sine, sine. So looks like there is a typo here. This is a backward. So put a now start here, because this is not a correct formula. Let's take a look at again why this is not correct formula. Correct formula is cosine comes first, then comes sine, then comes sine. So going back here, I would say, oh, my bad, I'm sorry. It is correct, but it's a minus. So you are doing backward. Cosine, cosine, sine, sine. Sorry, my bad. It's correct. I didn't realize it's a minus sign. Okay, so this is cosine, cosine, sine, sine. So it's a cosine. Pi over 8, pi over 16. Cosine get the opposite sign. That means add. And 3 pi over 16 is not on a unit circle. You stop here. Pi over 7, pi over 3, you are supposed to add. How do you know this is a plus? Because this is minus. Why this is minus? Because cosine, cosine formula is backward. That's why this is minus. Okay, so let's give a try here. Sine, cosine, cosine, sine. That means this formula is a sine. Sine get the same sign. That means this is minus. Pi over 9 and pi over 5. Add them or subtract them. Cosine, cosine, sine, sine. That's the same thing. So let's take a look at here. You have to know how to add, subtract these fractions. One more here. Cosine, sine, opposite sign get the same sign. Sine get the same sign. Sine get the same sign. Alternate function, which means sine. Same function, which means cosine. Formulas are not that difficult. Okay, so I'm going to look at some examples here on the test question, and then many times we assume. What is a supplementary angle? Supplementary angle means the sum of the two angle is 180 degrees. 180 degrees means pi. So how do we know this is a true? So we have to use the cosine. Cosine means a cosine pi minus b. Subtract is equal to cosine a. Use the formula cosine pi cosine b, sine pi sine b. Cosine of pi is -1, sine pi is 0. So this become whole thing is 0. Cosine of A is equal to negative cosine B. In other words, if you add them equal to 0. So this is a true statement. But it is not true other way around. So let's check why. This says if cosine A plus B is 0, are they supplementary angles? So come up with the angles where individually they are 0, but the sum of these two is not pi. Supplementary means 180 degree, which is only 1 pi. So clearly very easy to figure out that 3 pi cosine 3 pi is -1. Cosine pi is also -1, and -1 and +1 is not 0. So and pi plus 3 pi, this is 2. My bad. Let me rewrite again. This is 2 pi. Cosine 2 pi is a 1. Cosine pi is -1. They are 0. But 2 pi plus pi is a 3 pi, and they are not supplementary angle. They are not supplementary angles. Multiple choice question. If these two are same, it is 0. Correct, because if they they are both same, so that number will be 0. um, you have to work backward and you have to find the amplitude. So amplitude is always 1. No matter whoever is there, amplitude is a 1. So summary is sine plus cosine, a sine sum of the two angles, cosine sum of the two angles. Make sure you have these 4 formulas in your memory and you know them cold. Thank you for watching this video.